Cool. All right.
All right. Hey, everyone. How's it going? Good morning. How many people like bats?
I like bats. Nothing wrong with bats.
So I asked that question everywhere, and oftentimes it's not really environmentally based. People like, oh, and so I was trying to make them change their views a little bit. Right? So today I'm going to be talking about the bat stuff that we've been doing here. Back here in northeastern Indiana, and what we've been doing just right out there. Right? So first off, bats are awesome. There's so many things about bats that make them extremely cool. Right? This one is an eastern red bat that I caught in Georgia, and the guy who was really great photographer, Michael Durham, if you look him up, awesome pictures. You would take these bats into a tent and set up a line break system where if a bat flew past this little laser, it would automatically take a picture. So using a pitch black in a little tiny tent, it had this set up, and it would take these really awesome in-flight pictures of these bats. And these we have just right out there. Very awesome, very red bat. Right? So bats are awesome for a lot of different reasons. First, they are the second most diverse order or group of mammals. The first most diverse is the rodents, right? And bats are not rodents. Bats are something completely different. They're actually more related to us than they are to rodents. And so it's very interesting. And there's about 1,400 different species of bats out there. And they are in every single place on Earth except for Antarctica. Right? And also the North Pole. Right? They have a whole bunch of ecological functions. Right here we have a pollinating bat who does the same exact thing as hummingbirds. They just do it at night. Right? And so they'll go around and they'll pollinate. And here we have a seed disperser. We don't have any fruit givers or fruit eating bats up here. But down in Central South America and below around the equator, you get a lot of fruit eaters, and they eat the fruit and then they go and poop somewhere, and that plants a tree. Right? So they are one of the only seed dispersers in a lot of different forests. And then, of course, they eat a whole bunch of bugs, which is really nice. Also provides some economic benefits. All of our bats around here in Indiana are insectivorous, meaning they eat just insects. Right? And so if they weren't out there, there'd be a lot more insects out there. We don't really want that. Right? That's good for not only the ecosystems or the environment. It's also good for us, right? They eat a lot of crop pests. In fact, there's a study done, not 2011, I think, that shows that bats in North America saved the United States about $3.8 billion worth of pesticides. All right, I'm going to take this off. Blast it. So $3.8 billion per year, and that's just only for corn. That doesn't look at soybeans, doesn't look at all of those other things, right? So if we didn't have our bats, we'd be paying a lot more in pesticides. And there'd be a lot more pesticides on all of our crops, which might not be a great thing. Right? So bats are extremely important, extremely awesome. Right? Up here, we have about 9 to 10 different bat species. Right? We can separate our bat species into 2 different groups. We have our migrating bats. And these are bats that migrate, just like our birds. We'll have bats that will migrate from Canada down to here, and bats that will migrate from here down to Belize in Central America. Right? And maybe even further, we don't really quite know. Right? The first one is the horned bat, Lesirus cinereus, and that is the largest bat in Indiana. This is a really big one, right? That is a horned bat, one of the prettiest bats that we have. It's kind of salt and pepper shaded, and it's got nice frosted tips on its fur and things like that. This one's a big female. You notice that the wings are really long, but that's pretty much all they are, right? Their body is about the size of your pointer finger, and it's not very heavy, right? So this might look very intimidating, but it's just all weight. Right? But this is the biggest one, and it eats insects. That's it. And I just brought it because I really like it. This is a skull over that. That's like magnified about 30 times. That's a skull. And I show this to my students. They go, and yeah, it's 3D printed, and we're actually going to be looking into skull morphology and how that changes where they can eat and what they can eat, things like that. And the grad students will be working on that, which should be fun. All right, so that's the hoary bat. We have the eastern red bat. And we also have the silver-haired bat, which is what we call our older bat biologists. They've joined the silver-haired club, right? So we call them the Lasionicterus, not the Bacon's club, and I'm starting to get there. But we'll see. Right? And then we also have the hibernators, which are, these are the ones that will go into caves or mines or up in your attic for the winter. Right? And that includes these 6, and they're all little and brown. They don't have a lot of diversity in what they look like, but they do have a lot of differences in how they live, where they live, what they eat, things like that. If you have a bat story, it's going to be the big brown bat. That is by far the most common bat in North America. And it's the one that is most associated with urban areas or suburban areas. It's going to be in houses, it's going to be in barns, in attics, in churches, anything like that. Right? Indiana bat, that's highly endangered. The northern long-eared bat, that is endangered. The emu bat, that is state endangered. The tricolored bat, and the little brown bat, they are about to be listed on the endangered species. Only one that's doing all right is the big brown bat. Right? So all of our hibernators, they're not doing it. Right? So all of these different types of bats have a couple of different types of conservation challenges. They're all at risk for some way, shape, or form. Right? For migrants, the challenges are actually wind energy. Wind energy is great. It's green energy, it's renewable, it's all that stuff. But it can be a big challenge for both bats and birds. Right? In US and Canada from 2000 to 2011, there was about 650,000 to 1,300,000 bat deaths. And this happens when a bat will fly up to a wind turbine and get clipped by it. And the edges of those blades are going 300 miles per hour. Right? So if they get clipped, they're not doing very well. Or if they're just around that blade as it goes past, the barometric pressure is so much that it can kind of pop, which is not very fun. Right? So just the vacuum causes them to die. Right? So that's not great, but we are working on it, right? We're working on it in that there's a lot of research looking into something called curtailment, which is shutting off the wind turbines when the bats are flying. And that ends up being when there's just not that much wind. Right? So the wind turbine isn't really making much energy anyway. So shut off the turbine blades at that time, so the bats are okay, and then just kick them back in when the wind's going fast. That's one way, but we're also looking at a couple of different types of wind turbines, more spiral shaped, that ends up not hurting the bats as much. So we're working on it, and there's a big push in both the wind energy companies. They really want to not kill bats and birds, but also the birding world and the bat world, we're all working together trying to figure out what to do. That's really hurting our migrants. For our hibernators, it's going to be white nose. How many people have heard of white nose syndrome? Yeah, good. Well, actually, back. I wish you didn't hear about white nose syndrome. It's really bad. It's a fungal infection by Pseudogymnoascus destructans, which is the white nose fungus, which is a fancy scientific term for it. It's also a fun word to say. And it's killed about 6 million bats that we know of since 2006. And that was a number about 5 years ago. So it's definitely multiplied a lot by that. Right? And it's some areas it's 90 to 100% loss of bats in a whole area, especially the northeastern United States. They have one species left of hibernators, and that would be the big brown. Everything else is just not there because white nose is just decimated. What used to be the most common bat species, the little brown bat, is just not seen. Right? I actually, my master's degree was working on them, so I catch them all the time. And then it was about 10 years since I caught them. I actually caught one with my students last year up in it's pretty cool, but it used to be the most common bat species of America. Right? It was introduced by dirty cavers in 2006. I say dirty because they didn't clean their spawn in here. They brought it over, we think from France, brought it over and went into Howe's cabin in New York. And the fungus then just went onto the walls there and started covering up our bats, and then the bats spread it. Right? And it kills a lot of bats. We would find whole carpets of skulls and wing bones and things like that from bats that died the previous winter. Not fun to see. Right? So white nose started in 2006. We started really seeing it in 2007. That's Howe's cabin right there in New York. But since then, it started spreading by bats. Bats they usually wake up every once in a while during hibernation, and they'll just go back and forth to different caves. They'll visit each other. And whenever they touch a cave wall, the fungus grows like really. And then another bat will touch it, and pick it up, and they go to another cave, and so on and so forth. Right, so that's 2009, 2010, 2011 in Indiana. Right, that's down in Crawford County, which is where one of the biggest hibernaculums of Indiana bats, the endangered bat species, is. And it was introduced there in 2011. 2012, 2013, 2014, 15, 16, so in Washington. That wasn't a bat, that was a person. Someone didn't clean their caving gear again and dropped it off in Washington. Right? But it's still traveling westward, South Dakota, Nebraska, Oklahoma, Texas. Now it's in California, it's in Wyoming. Now it's in Montana, more in Texas, which down here, that's San Antonio and Austin, which is where the Mexican free-tailed bat is in populations in a single cave that has like 4 million bats in it. And if that fungus gets in there, that's a huge, huge decimation of that population. Right? And this is where we are at in 2024. It's happening. There's not a whole lot of things we can do about it. So we kind of have to face the music and say, okay, what's going to happen after it's run its course? It's not fun to think about. Right? And the reason for that, it's really difficult to reduce infection and mortality. Right? It's really difficult to apply disinfectants. If we were to do that, which it works, I mean, we could dump every single bat in bleach and it would kill it. It wouldn't like that, right? But the problem with that is we have to catch all, let's see, I do a hibernaculum survey in Southern Illinois, and there were 65,000 Indiana bats in that one cave. So grab every single one of those and dump that in bleach, that's going to take a while. You can also backpack spray it, right? But that's not going to get every single crack throughout the entire cave. And if we miss just a single speck of that fungus, it's just going to repopulate. Right? So that causes it to be easily reinfected. Even if we kill everything in that one cave, which is hard, all it needs is a single bat from another cave to just come in there and reinfect the entire cabin. So, really hard to do that. So we are trying to place effort into increasing recruitment in bats, which means conserving summer maternity colony habitat. So maternity colony, that's where the females hang out and they raise their babies like that. So we want to increase recruitment. We want to have them make more babies, because if that can cancel out the numbers that are dying for white nose, they're going to maintain our populations, at least some. Hopefully until they adapt and are able to resist that fungus, which is actually happening. Slowly they are adapting resistance. But will it be in time? Not quite sure. Right? So we want to make more bees. This is a chimney in an old abandoned church in Southern Illinois. Each one of those specks is a little brown bat. They're all females. They roost together and raise their young together. If we can make more of those roosts and just make really optimal places to raise young, then maybe they'll start repopulating. Right? But there's another conservation challenge for all bats, and that's habitat. So if we really want to kill bats, we need to save their maternity habitat. But the maternity habitat is lost. All right? They really like these really tall dead trees, standing dead trees we call snags. And they will roost underneath the bark that's hanging off of them. And in a single sheet of bark about this big, you'll find up to 200 bats underneath. It doesn't take much, but they really like very wide open, really sun-baked trees. To have those, you need to have really big trees. And to have really big trees, you need to have older growth forests. Or this is a cottonwood. Cottonwoods take 4 years to decide. So you need to have really good recruitment of big trees. Right? But we have deforestation, which is happening a lot. This is the historic forest coverage in the United States. In 20, this is where we're at in 19. It's gotten better than that, especially here in Indiana. This is the Hoosier. We started getting Yellowwood and Morgan Monroe Forest and some other good natural areas, so we're getting better. But it's nowhere near where the bats first evolved into. Right? This is what they're used to. This is what they got. So we got to really work hard on that, right? We need to conserve quality. Right? So bats are awesome, but bats are also very sad. They need our help. Right? So overall, bats are in trouble. About 16% of all known bats are threatened or extinct. Can't do anything about the extinct. There's another 18% that says is unknown. We know about the species, but we don't know how they're doing. So that means about 500 of the 1,400 species of bats are probably going to go extinct very soon. And this includes our northern long-eared bat and our Indiana bat. If we don't do something about them, we're not going to have it. And we know that they $3.8 billion in pesticide services. So they're really important. Right? So that's the objectives of my research. Right? This is a bat fox over near Indianapolis Airport, and those are endangered Indiana bats coming out of them. So I study the bat communities in the Midwestern United States. I've also been down to Peru and Southeastern United States, but mostly I'm in the Midwest. And I look for the presence of threatened and endangered bat species. And I look at how they use habitat, what type of trees are they selecting, what type of areas do they need. And talk about, or I look into the impacts of disturbance like forest harvesting, right? Timber harvest. Turns out that that's not really impacting Indiana bats very much, as long as it's good harvest and not over harvested. Right? And I do all this to help inform the conservation of our Midwestern bats so we can continue to have them. Right? That brings us to Eagle Marsh. So I got here back in 2017 in the fall, and I was a visiting assistant professor up in Fort Wayne, which means I was here to teach, but I wanted to be here permanently. So I started looking around, what type of natural areas are around here? And I drove by Eagle Marsh all the time, going through I-69. My wife actually grew up here, and we go and visit the parents, and I look at the marsh like, oh, that's such a great place. Right? So I started looking into it, and a lot of my coworkers had been working down here, like Dr. Mark Jordan, who works on turtles, and various other things. And I did also know that in 2014, there was the Indiana Academy of Science BioWorks, in which they looked at mammals, frogs, snakes, turtles, insects, plants, everything but bats. To bats, mostly because they asked me and my lab to come, but I couldn't, so I wasn't here to do it. So I decided that maybe we should do that. All right, especially since Eagle Marsh is such an awesome place. My students going back into the northern forest back in that was 2018, where there's just that huge flood. Really awesome place. And so we were trekking back there, and I was looking around for bat roosts and things like that. There's a lot of different habitat that is really good for our endangered bat species. They like wetlands. They like forested wetlands, right? And we have a lot of that here. So it smells like endangered bats too. I was looking around, but there's got to be something. All right? Never, this endangered bat, Indiana bat, has never been detected in Allen County, which I think is wrong, because they're present in all surrounding counties. I just think no one has looked here. Right? So my objective was to determine if the species was present or not. Right? So we did some work in 2018. We had one of my undergraduate students, Erica Miller, used acoustic detectors to record bat echolocation in Marsh. And we do this, the echolocation calls, the echoes, the ultrasonic calls, they're actually species specific. So if we record them, we can actually listen in and see which bat species were there. Right? So this is the call of the big brown bat. This is in kilohertz of frequency, so this is well above how high we can hear. And this is the big brown. Well, actually, that's the Indian bat right there. Right? And we do things with, this is kind of not a great one, but this is a ultrasonic detector right here. And there's all sorts of ultrasonic noise around here, especially lights, computers. They all make ultrasound, but we can record that. So we can use that to record bats and kind of slide there it's not. Right? So Erica did a lot of work for an undergraduate. She was out there all the time. She set up places, or these detectors right here, about 14 different sites. One of those was way back here past the railroad tracks and in that flooded area. So she was trekking through that area and sticking out the tripod. She did a lot of work. Right? And that was all during the summer of 2018. And this is the results. Number of bat calls of these different species. We got some little brown, northern long-eared, and Indiana bat calls. So that suggests that we detected Indiana bats with the acoustic detectors. Right? But we can't be 100% sure that they were actually there until we catch them in the hand. All right? The problem is that some bats have very similar echolocation. Right? You can almost determine between them in some cases, but they overlap a lot. Right? And that's especially true for the Indiana, the northern long-eared, little brown bat, because they're sister species. They're very close to each other. Right? And evolutionarily wise. Right? So we can't be certain which one of those species was present unless we catch it in the hand. That's a really, really chill Indiana bat, and they are very, very chill bats. They will just hunker down in your hand and then just be nice and warm and toasty. Versus a little brown bat, they'll just be like, they'll be freaking out. Right? You can tell them apart just based on how they hang out with you. Right? But in order to prove that Indiana bats were here, we did a mist netting survey in 2019. We're actually out there in the wetlands, in the forest, setting up bat mist nets in order to try to catch them. Right? So we did that in the southern forest here in Eagle Marsh, and we also did some stuff in Fox Island. And we did stuff in Fox Island because it's a nice big forested area. That if the bats are found here, they are most certain in Eagle Marsh as well. Right? Bats have home ranges. Normal foraging areas of miles. So if they're in there, they're definitely. Okay. So in order to do that, we had to set up some really big mist nets. Right? Mist nets are essentially just on flagpoles, and it's really hard to see them because they are very thin, but that's one that's wrapped up. And I call them essentially hair nets that we stretch across whole trails or rivers or something along those lines. Right? They are very fine mesh. The bats can't see. Bats actually can see just as well as you or I. They can't hear them with echolocation very well. They still can, but sometimes they get caught. So that's a mist net right there. And that bat is a little brown bat, essentially flew into it, and it sags down and it kind of captures them in a hang. Right? And they hang out there, and we check the nets every 10 minutes. And then if we catch one, we just carefully take it out and we ID it by hand and we do spot it. Right? So we identify the species based on some key morphological differences, how they look, some other important things. Right? That one looks like a big brown bat. And then we check the bat's health, if they're infected with white nose. The age, we can determine if they are juveniles or adults. That's about as far as we can tell. The sex, their size based on their forearm length and how heavy they are, and some other different things. There's a bat that we're checking for white nose. If they have white nose, you'll see a whole bunch of specks on the wing, and that is where the wing had been necrotized, so the fungus had actually eaten the wing. There's now holes in the wing. But the good thing about bats is that their wings heal within 2 to 3 days, really quickly, right? Give maybe a week. So if we see little holes or little white spots on the wing, that means it had been eaten, but it's healed inside. Right? And we didn't see any presence of white nose. That's because usually the wings will heal about the second week in spring, right? So they come, the bats leave their hibernacula in the spring, and then their wings heal very quickly. So we don't usually see this kind of stuff in the summer. Okay, there's a big brown bat that sounds too happy. I mean, I always say that if there was a giant that had grabbed you, wouldn't you like, do the same thing? Yeah, totally. Right? I usually try not to do big thing pictures because it makes it look scary, but you all like that. Right, so during that 2019 survey, and we surveyed how many nights we did. We did at least 12, at least a dozen nights, something along those lines. We found northern longyear bats. We didn't find Indiana bats. We actually found this species, which is the sister species, northern longyear bats. And they called that because they have just slightly bigger ears. It's right there. Right? We found one adult female and one juvenile. So we got an adult female, which means, yeah, you guys have a maternity colony, which means this state endangered bat and federally threatened bat should actually be federally endangered, should be added to the two. It has a maternity colony just right out there. And this bat is, you might have to So there's a maternity colony right out there, which means that's a really important place for the species that we actually hadn't caught in Indiana at all for about 3 years. This is one of the first captures of this species in about 3 years. We used to catch them all the time in southern Indiana, and then we stopped because of the wings. They're right here. Right, so we targeted. We affixed a radio transmitter to the adult's back, like that. That is a tiny little radio transmitter. It's essentially a radio antenna. It's about a beep. Right? And that bat, we attach it using the glue, just regular glue. And well, it's not Elmer's, it's actually surgical glue. But that'll stay on the bat for about a week or two, depending on how good I was at putting it on. Yeah, crest. So these guys, the northern longyear bats are really good at taking them off. I don't know if their buddies are really good. They just rip it off. This Indiana bat right here, it'll stay on. I got really good, and it would stay on for about 3 weeks or so. Right? This is an Indiana bat, by the way. And then we released it, and there's Alex. You have to boop it on the butt to make it go. But that's over in the gazebo in front of the nature trail outside. Or no, that might be by the lake. Yeah. And then we track it back to its roots, and that's me about a decade ago. Right, tracking it, Indiana bat in southern Illinois and swamps. Right, so we use big radio antennas to try and track it through the forest. Right, and the maternity roost where we tracked it back to was a silver maple stag, standing in a tree, located about 10 feet south of the train tracks. Right there. So there's the train tracks. It was just right off the train tracks. Me and Betsy had the hardest time trying to find that roost. We started in from Fox Island, and we tried to track our way this way. We thought it might have been just right past the woods, but no, it wasn't there. So we had to come all the way back to Eagle Marsh and go somehow. I don't know how we did it. Didn't it? No, we did. We crossed the tracks. And jumped into the.
I have no recollection.
Yeah, I know. I did. It somehow reminded me. Right, and so yeah, we didn't pass that at all. So here's the tree, and the tree is in here. You see it?
Yeah, sure.
There's the flag we did. Every single one of these trees. And that's great because that means that that's fine. Right, so there's a lot of roost availability there. Right, so this just caused more questions, right? What are they doing here? Right, I was expecting the endangered Indiana bat, right? These are deep forest bats. And by deep forest, I mean Appalachian Mountain type forest or Hoosier National Forest. Really deep forests, right? Our forests just don't get that deep. Right? We have some great woodlots, but they're not as big as where we usually see these northern longlegs. It's also adjacent to the second largest city in Indiana. And these are not urban bats. So what the heck are they doing? Right? Also, why did the northern use a roost that looks just like a roost that an Indiana bat? Right? I went out there and I said, this is an Indiana bat roost. There's no way that this bat could be in there. And it wasn't. Right? This is a northern long-eared bat. A little woodpecker hole in the sassafras tree. They like really shaded trees, and this bat was in a tree that is used by Indian bats. Just more questions. Why was it using that? Right, so the great thing about all of that work, both Eric Miller and then Alex Barton actually started writing it up, and we actually published that work just last week. So, woo! There's some good Eagle Marsh.
Very good, yeah.
Little River Wetland project work out there.
Where is it published?
This is the Indiana Academy of Science, and I can share. Well, I think you already have the PDF, so we can share it as much as you want. Right. So that brings us into 2020 and 2021. I had a master's student come in. This is Galen. He is a master's student that started in 2020. So before the pandemic was really raging. And we thought, oh, we're going to get out there, we're going to net so many bats, and then the pandemic hit. And we actually couldn't net until July, which happens. But we still got out there and we started netting bats, right? But he had a couple of different research objectives. One was to study the colonies, selection of roosts. What type of roosts are they actually selecting? What are they doing out there? We're going to fix, well, we did fix transmitters to a bunch of them. And we compared the characteristics of the roost and what they, the characteristics of whatever trees that they're using to just a bunch of random trees that are out there, right? So if we can see if there's any differences between what they're actually using and what's available to them, we can see what actual trees they really like in their trees, right? Like, do they like taller trees than what's available out there? Do they like really shaded trees? That's how we're going to figure that out. Right? See how the colony is using torpor, which is something that I specialize in, which is kind of daily bouts of hibernation. almost like they go into cold storage every single day. And that helps them save a bunch of energy. And so we recorded a bunch of skin sensors from our bats to see how they're using that and how that relates to what type of trees they're using. If they use a really shaded tree, they can go into torpor really easily. If they use a really warm tree that's exposed to the sun, it's really hard to do. So they can change what type of tree they use and produce different torpor.
Would that influence where you put your bat house? Would you want a shaded bat house or sun bat house?
What I usually say is, if you can do it, I put out a bunch of different types of roosts out there. Right? So whenever we advise management companies or state forests, we usually try to say, make a bunch of different types of roosts available. The ones that the bats are most going to use are those really solar exposed bat boxes. So tons of sun throughout the day. That will have, good segue. There's a big brown bat in a bat box. Well, it is really, but it's not a lot. This one bat box is going to hold probably up to 100 Indian bats. Probably more like 25 big browns, because big browns are about twice the size of Indianas. But it'll get packed if it's solar exposed and the bat can eat. Right? If you have a lot of forest nearby you, there's probably other roosts available to them, and they might not use the box as much. Also, it might take some time for them to use the box. We put up 3,000 bat boxes in the forest around the Indianapolis airport. About 10 years later, they started using it. So it can take some time.
What percentage of those are being used?
Right now, that's all they're using. Because all of their trees that they had, they all died. Yeah, so all the really nice big snags, they fell over. So now all that's available to them are these bat boxes. And if those fall over, or we stop using or making them, then that bat colony has to stop. He also conducted an acoustic survey that compares bat communities in and outside of the Fort Wayne limits, or city limits. This is kind of a last minute project that we started because of the pandemic happened. And actually, it's going to end up being very interesting. All right, and we can talk about that first. Conduct an acoustic survey that compares. Essentially, we're asking, does bat diversity activity change between urban and natural or rural natural areas, right? So it's hard to see, but this is a map of all the spots that Galen set out acoustic detectors. We have Spring Lake, we have Arrowhead, I think we have LCH Park, Fox Island, Eagle Marsh. We have a site that's over in the new, or Eagle Marsh West, I think it's called. And inside of town, we have one of the Botanical Gardens, Lindenwood, Froggy Park, the zoo, Johnny Appleseed, and we also have Solomon, and then all of Matana, all sorts of places. We have a lot of acres sites, right? And essentially, he puts up a really nice bat detector on top of a painter's pool. You get it elevated because that's where the bats are. And this is one, what is this one? Lawton Park, just right across from the city, essentially. We put one up right there. Right? So Galen is finishing up that analysis now, so stay tuned. He's graduating next semester in the spring. So keep but I can show you some results of right here. This is the results from the 2 years of his work from Eagle Marsh West. Right? So over the 2 years, we got different amounts of calls. Most of them are going to be big browns. But we did see a lot of hoary bats, which is interesting because we never catch them. We don't catch them because they're very high flying bats. They don't come down and visit us with our 20-foot nets. We have to make like a 4-tier net. That's just not possible. We got eastern red calls, we got silver-haired bat calls, which those can actually be misidentified. They're probably a lot of big browns. Some Evie bats, some tricolor bats, which I don't see anymore at all. They are being devastated by whiteness. So a decent amount of different types of bats, more than what I would expect in a close to urban area. Okay. So he also studied the roosts right? And we can look at the results of the back captures that the bats that we caught during this particular project. And here we have 3 years of data. We got a lot of big browns, right? We got 130 this year. We had a lot more net nights, a lot more effort, right? But 130 big browns. Eastern red bats, we caught about 20. We caught some silver-haired bats in 2019. And then every single year, we caught a couple northern longhorns. And that was about it. So a lot of big browns. Lots and lots of big browns, which is a great training bat. It's the biggest bat they're probably going to handle. They also have the biggest teeth. So they get to learn really quickly how to handle a bat correctly, or else they might get bitten. But we do have gloves on, so it's not a big deal.
Do you worry a lot about rabies? Yeah.
We all have our rabies vaccinations. So if you are going to handle that, you need to have up-to-date rabies vaccinations. But very rarely will we ever come across a rabid bat, because when bats are rabid, they're out during the day, they're flying inconsistently, right? So that's the only time I'd be worried about a bat, right? When they're out doing their normal natural activities, I'm not worried about it, right? But we still have to have rabies vaccination, right? Even out during the day, if you come across a bat, if it's flying away from you, if it's hiding, that's probably not rabid, right? Still don't touch it, but it's probably not rabid. If it's flying like it's drunk or flying towards you, like actively flying towards you, not trying to get away, then probably just like, okay, no, I'm not going to mess with you even more. But foxes, raccoons, and skunks carry the most amount of rabies, not bats. This is a red bat. We caught 20 red bats. It was very nice to see them. Again, they're probably going to be listed as a danger. Right? So, study the colony, selection of roosts. You likely have about 7 bat species here in Eagle Marsh. You got the big brown, you got tons of those. You got eastern reds, not as many, but you have them. You got silver hairs, very rare. They tend to migrate through here. I was surprised that we actually found reproductive females, which suggests that they're actually roosting here and using it very well. The northern long-eared bats. And these are the ones that we know. We have confirmed by hand that they are here. Probably have hories, but it's going to be very hard to confirm that. But based on the acoustic survey, you probably have them. Evening bats, probably, but I'm less sure of that, so don't quote me. And then like, the same thing with tricolors, they're the smallest, they're so cute. Probably have them, but it's so low numbers that it's going to be very hard to actually capture them. Really wish that captured them. They're so stinking cute. Right? Results of the roost selection, we tracked 4 northern long-eared bats to 12 roosts, which is not bad. And bats primarily just use those silver again and again and again and again. Right? They roosted under that exfoliating bark, so the bark that's kind of popping off. Sad. And the colony was actually only about 8 bats, give or take. And that's kind of usual for the northern long-eared bat. They tend to be in very small colonies. I think the biggest that I've ever seen is 24. Versus the Indiana bat colony, which can be up to 300, right? So not as many. But 8 bats is still good, and we confirmed that it was 8 bats by conducting emergence counts. So here's Galen sitting underneath a tree as the sun is going down, and during right around like 30 minutes after dusk, the bats will start emerging from the trees. Right? And I think this is actually the day in 2020 where the comet was just going right past here. That was pretty cool. Right, so very pretty. We saw a bunch of red-headed woodpeckers all throughout there. It was very nice. It's a fun thing to do. You just need a lot of insect repellent. And this is our map. Right, so all of the white squares, that's our net sites. All of this star is the 2019 roost. The triangles, 2020 roost. And the circles are the 2021 roosts. And there's actually a lot in between there, right? These are the only 2 or 3 that are actually in forest, in shaded forests. All the rest of them were in this belt of nice silver maple snags. There's just so many good roosts there. The bats have a ton of trees, so they just hang out there. Okay, by the way, we are there. So what does it all mean? Well, fossils provides incredible roost habitat for bats within the landscape that's devoid of it. There's not a whole lot of wetlands that are here, let alone this great wetland that we have. So really, this is a diamond in the rough when it comes to wetland areas that all the bats are just going to flock to, right? A bunch of habitat that's available. And more than just urban bats are able to occupy the site. You have a ton of big grounds that are probably roosting just up in the buildings up there. But we still have some really, deep forest bats that are able to be here. Right? A flooded northern area provides tons, Fox Island provides tons of great bat habitat, great bat roosts. And there's a maternity population of state endangered, federally threatened bats in Allen County. And maintaining a continuous supply of similar roosts to what they have been using will help maintain that population here. So if we keep providing them with similar roosts as that, they're still going to hang out here. And this might be one of the remnant, one of the last remaining maternity populations of this bat species in Indiana. There's not many of them left. And this might be one of the only places.
And maintaining that means flooding old maple forest.
Or just somehow, all it really means is big trees. Big trees that are allowed to die and then stand, right? So there's a bunch of different ways to do that. Obviously, flooding is a great one for wetlands, but sometimes you're not allowed to do that, right? Or that's not, right? So allowing trees to grow up, and then when there's not a lot of dead trees, maybe putting up some bat boxes. Northerns rarely use them, but they might if they're forced into it. So all those things are possible.
So they usually are on dead silver maples.
Yep. When they were on live trees inside the forest, and that was cottonwoods. Cottonwoods sometimes provide some of the soaring bark. Shagbark hickories are also really good ones because they just have naturally bark. All of those are pretty good. And they're mostly on the dead silver maples because that's what's there. That's one of the only trees that are out.
They were killed from flooding. For some reason, that land flooded where it had from decades.
Yeah, there's probably also just some regular flooding that would also kill them. And the trees are going to die every once in a while anyway. Silver maples don't live that long. So just natural senescence is going to allow for what I call a snag recruitment cycle. So if we just continue to have more and more snags, eventually the ones that they're using are going to fall over. If we allow more snags to grow up and die and make good roosts, then once those die, they can move to other ones. Then once those die, you can move to the next batch of snags. So a good, healthy snag recruitment cycle is going to allow these guys to hang out. Okay, so that's what we have going on. I think I'm just about done with time. I fast. But we can talk about what's going on now. I have another student, Deanne, who's done a lot of stuff in Eagle Marsh and around here. Is another master's student that just started, and she is looking into neonicotinoid insecticides and how they are affecting our bats. These are the pesticides that are killing all of our bees and a lot of other things. And she wants to see if the bats are being exposed. And these pesticides are the most frequently used pesticides in the world, throughout the world. And it's been found that it's actually killing off our birds, like the eastern peavy. So if it's affecting the birds, this is an insectivorous bird that it should be affecting our insectivorous bats. So she's looking into whether or not they're exposed to it. And then if they are exposed, we're going to look into where does that exposure come from and how does it affect their health, right? So does it come from their water? what their drinking sources or their insect prey, both of which could transfer it. We're going to look at their body conditions, their immune system, a couple of different ways to do that, and their cortisol levels, which is stress hormone. If they have a ton of cortisol, that means they're constantly stressed, right? And we're comparing that to a population that's up in Michigan, where there's less neonatal. And if we see if they're very different, well, that's a problem. But if we see that they're similar, then these bats are just fine. And there's a big brown bat that we are extracting some blood from. We kind of use a needle, poke them, and then we extract the blood, and then it heals over a couple of seconds. They're very good at healing. The sample is analyzed. Hopefully, we get some ideas of what's going on probably next month. Right? Some other stuff that we are doing, not only bat stuff, we're also working with Mink. Ellie, another master student, is looking at eDNA, which is environmental DNA. You can pick up samples of water. You can extract any DNA from that, and you can see if your critter's DNA is in that water. If it is, you have that species here. Right? And she's trying to determine if that's useful for detecting mink, which is kind of an elusive species. Right? So she's doing a lot of labs. She's also looking into camera traps and how you can effectively camera trap or use camera trap to track semi-aquatic mammals. Right? So she's doing the lab work right now. It's actually working out really well. We'll get the idea of what's actually happening probably the end of here. Right? But we do have good camera trap pictures of semi-aquatic mammals. We put up a bunch of camera traps just over by the barn, and we got a lot of cool pictures. There's Mr. Beaver. There's Mr. Beaver and wife.
And wife, okay.
Mink.
Wow, hard to see.
This guy has a home right there, and it's right across the barn. And that isn't a semi-aquatic animal. That's an owl that's hunting. That's the eyes being reflected off the water.
There he is.
Yeah, the eyes are right there. So I really want to send this picture around and see if this is one of the first things of this, or observations. Right. I also have some undergraduate students, Carson White, Latavia Jenkins, Trevor Proctor, and Jessica, who just graduated. Undergraduate students, and they are looking at a novel camera trap method to try to detect small mammals, to see if it's better than good old box trapping. That's a box trap. Line trap, we call them short traps. If you're walking hiding through the woods, you probably saw them, potentially. We're comparing that to this. This is a drift fence, and anything walking through this forest is going to hit that fence and be funneled down towards one of our buckets. In that bucket, you can see right here is a camera trap. It's looking down. So it funnels these small mammals into the box right underneath the camera trap. Camera trap takes a picture. We have a recording of what was there. Right? And we don't have to, I go out there once a month to download the data. For the Sherman boxes, we have to go twice each week and spend a couple of hours out there. And so it's a lot quicker.
Why can't I look it out?
There's another hole just right on the other side of the bucket. And to get out of this box trap, we actually take them out, look them, ID them, and then toss them out.
So the fence is like buried
in
the ground, so they can't go under it.
Yeah, that's the only way you can get it. Turtles are big underneath. Have we ever found a box turtle here? Yeah, very rare. So if you see this, these guys are still out there. We're keeping them out there. He's out for years. Kind of looks like garbage. Like someone just tossed something out. That's research. So we're analyzing this stuff right now, but I can show you some pictures. That's Bergeson. That's a field mouse. That's a native mouse. We catch a bunch of those in the Sherman tracks. Yep. We don't catch those in the Sherman tracks. That is a northern water snake. Very cool. Harmless critter. We also got garter snakes and one frog. I only got one frog. That one's a shrew. That is one of 3 venomous mammals in the world. That's the short-tailed shrew. If you catch it, don't worry, you can't eat it. It won't bite you. But maybe just don't handle the shrew. Yeah. That is a Zappus hypotodicus. That is the meadow jumping mouse. And this is an extremely rare critter. And the first time we eat it was in our camera trap. But just this year, we actually caught it. And its body is about yay big. Its tail goes up to about there. It helps, it's like a cheetah tail almost. It helps it, or a kangaroo tail. It helps balance. Right? They also have, their feet are about half their body size. They jump. Very cool animals. Very excited to see that.
When I was around 10 or 12.
Yeah.
And the zoo said, "Oh, we should save it for us. We could have traded it to another zoo."
Yeah.
Oh, I see.
Cool. That's not a mouse. That's a squirrel.
They get into everything.
Yeah.
Poses with the camera.
Yeah. Bye.
Wow. Cute.
That one you fit into a short dress.
Awesome.
So you don't even have to use lure on these because they're just walking along.
Yeah. I have caught a juvenile possum in my shrimp trap. Shrimp trap's about this big. Possum with the tail is about this big.
Oh,
It just shoves itself in there. It's got a free food and a free house during the night. And so oh yeah, there's bait, peanut butter and stuff. And not in here in the box traps.
Go in a box.
Yeah, and so we just let the juvenile possum back out of the box and just let me catch my mice, and then I can hold the next day. Just stick out. It's just free food. Yep, try. That is a long-tailed weasel. Long-tailed weasel. You will never, ever, ever catch one of those unless you're extremely lucky. And we have ID'd it here on Eagle Marsh. It's extremely hard. We also got another picture. I couldn't find it of a mink as well. Yeah, the mink going through here as well.
How big is the opening? Is it
Opening
and an exit?
it's about like that big.
Okay.
Right, so enough for a coon head, but not for the line. Right. So without even doing statistics, we know that the camera trapping is better than the Sherman trapping. We pretty much only catch the field mice in the box traps. So it's doing better.